Logarithmic differentiation. The method of differentiating functions by first taking logarithms and then differentiating is called logarithmic differentiation. This approach allows calculating derivatives of power, rational, and some irrational functions in an efficient manner. In this first example, the first step would be to take the power to the front and take the natural logarithms of both sides. As you can see, here we have a multiplication. We must differentiate this expression using the product rule and keep in mind that y is a function of x. On the left side, we derive the y as 1 over y times the derivative of y. To have the derivative of y in the left side, we must pass this y multiplying to the other side. We already have this value of y. It's right here, it's the original expression. So we must substitute the original function to this y in the right hand side. We can simplify a little bit further by multiplying these two. So the answer to the derivative of y would be this.
We're gonna solve for this problem. Y equals cos x to the ln x. We derive or we bring down the ln x, which it is this one. Then we add natural numbers from both sides, ln to cos x and ln to y. Then we derive ln y to here. It is 1 over y times y prime. And this we use product rule, which is u, this is u and this is u, times derivative of d, this one is the derivative of this one, plus derivative of u, and times v. And we pass this y to this side and it passes multiplying, we erase this, and we finally substitute for y with the original function, and it becomes cos x to the ln x, and this is the answer.
We're going to solve this function with logarithmic differentiation, and the first step is multiply everything by natural log. Once we multiply everything by natural logs, we are going to derive the natural logs of every single function. Once we derive every single natural log of every function, we are going to continue by eliminating the common factors in every fraction. For example, here we can eliminate the ex squared, and here we can eliminate the tan cubic and leave one tan. The next step is that we are going to leave y prime alone, so we are going to pass this y multiplied by everything. And the final step is that the rules of differentiation of the logarithmics is that this y means or is the same as the original function, so we're going to substitute this y for the original function. Once we replace the y for the original function, this will be the answer of the function solved with logarithmic differentiation.